Hey guys, welcome back to the Pepcoding. So in this video, we are going to discuss our next question, that is count inversion. So in this question, we have given an array and we need to tell how much amount of inversions that array can form. So what is the inversion? Inversion count is the count indicates how far the array is, how far or how close the array is from being sorted. If array is already sorted, then inversion count is 0. If the arrays looks like this, then the inversion count is 0. And if it is sorted reverse order, if it is in reverse order 4 3 2 1, then its inversion count is maximum. Okay, maximum. Now for formulate two elements, a of I and a of j forms inversion if a of I is greater than a of j and I should be okay. Two conditions, a of I and a of j. So the index of this is 1 2 0 1 2 3. So this and this, for example, this and this. So array of I, that means array of 0 is greater than array of 2. So 4 is greater than 2. So this condition is true, and we also need this condition also true. So that, what is that condition? I should be less than j. So I is here 0 and it is 2, j is 2. So these two conditions are true here. So if these two conditions are true, then inversion form. Now we need to tell the count of that inversion, how much inversions we got in that array. Okay, so what is the brute force method? For what is the brute force approach? So we are at this point and we are starting another loop from I plus 1, and it is checking how much amount, how much numbers are lesser than me, and it is increasing the count. So we are running this loop again and again. We are checking again and again every point. So it will be run and it will be cost us of O of n square, and we need to improve this time complexity. So we are going to use the merge sort here, and it is O of log n. So the time complexity when we are using merge sort, the time complexity of the merge sort is log n. So we are using n log n. Okay, so we are using here merge sort. So this is an array. So let's use the merge sort over this. So low is 0 and high is at 6. So now I'm writing here low comma high. Okay, so 0 comma 6. So first we need to find mid. So mid here is 3. So now first call on the left and on the right, that is from left low to mid. What is low? 0 and mid is 3. Right call is mid plus 1, that is 4, and high is 6. Again finding the mid at this point. Mid is 1, and at this point mid is 5. Again two calls, left and right. The left call is 0 to mid and mid plus 1 to high. Here two call is low to mid and mid plus 1, that is from 6, 5 plus 1 6 to 6. Again finding mid. Here mid is 0, mid is 2, mid is 4. So again two call from every position, left and right. Two call. First call is low comma mid, that is 0 comma 0, mid plus 1 comma high 1 comma 1. From here 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, and it is at the sixth position. Now we need to find the count of the inversion. So and for the sorting as well as sorting. So now we are at 0 comma 0, and it returns array, one array, and it contains 0th element of the array. Now we are at 1 comma 1, we are returning from 1 comma 1. So at this position we have 5. Okay, so at this point we are checking that is array of I is greater than array of j. Yes, 8 is greater than 5. Is 8 is greater than 5? Yes, 8 is greater than 5. So we are writing that 8 is greater than 5, and our count is first 0, now plus 1, and merge these two, 5 comma 8. Okay, so we got one inversion count. Now at this point, 2 comma 2 returns 3, and 3 comma 3 returns 4. So at this point 3 is not greater than 4. Because of 3 is not greater than 4, it did not increase our inversion count. So merge these two and return over this. So these two arrays, now we need to find inversions in between them. So first 5 comma 8, and it is sorted order because we are sorting here. At this point we are sorting these two. At this point we are sorting at these two. So first one is this, second one will be this order, this array. So it is in sorted order, it is also in sorted order. So now let's place I and j and take one array for filling that and merge that in sorted order. Now we are at I. Is 5 is greater than 3? Is 5 is greater than 3? Is array of I is greater than array of j? Yes, this condition is true. Absolutely true. So if this condition is true, 5 comma 3, we are returning the pair 5 comma 3. If this condition is true, then we can say that 8, this 8 and all the elements, if suppose 9 10, it will be written 9 10. So all in the sorted order. So we can say that all the element in this array is greater than 5 is also pair with this. Why? Because 8 comma 3 is also pair. 8 comma 3 is also pair. So we can increase our count by 2. If array of I is greater than array of j, then we are increasing our count by 1. If array of I, if this is the I, and we are checking array of I is greater than array of j, yes it is greater than, then we are again increasing our count. So we are increasing our count by 2 here. Now we compare these two elements, and if whichever the small element, add this into that array and update that index. Now we are at j. Now again, is array of I is greater than array of j? Yes it is. So again it can be formed two inversions, that is 5 comma 4 and 8 comma 4. Two inversions again plus 2. Now whichever is the smaller, add this into array and update its index. Now it is out of bound. So just write these two elements here. Now the sorted array from mid to low, from low to mid, low to mid is 3 4 5 and 8. It is 8. Okay, so from this it is 8. So 3 4 5 and 8. Okay, from this side we got an array and we got an inversions. So now let's run from this. Now we are at this point. 4 comma 4 returns 1 and 5 comma 5 returns 6 from here. Okay, now we are at 6. Now at this position 1 comma 6, it returns 1 comma 6 here, 1 comma 6, and it is not form any inversion because 1 is less than 6. It is not form any inversion, and it merge sorted. We are sort this and add this into, at this point 6 comma 6, 2 returns. At this point we have 1 comma 6, 1 comma 6 and another array 2. So we want to sort also them. I is here, j is here. Let's check, is 1 is greater than 2? No, it is not true. Then add the smallest element and array and increase their count, increase their index. Now I is 6 is greater than 2? Yes, it is greater than 2. So we have another pair and plus 1 count. Now add, check, compare them, whichever the smaller, add them this into this array and update the index. Now update this 6 into this array. Now the sorted list from mid plus 1 to high is 1, 2 and 6. So this is the sorted order from mid plus 1 to high. Now at this point again we need to check these two and we need to sort this. So at this point, very interesting point, this is a very interesting point, it got us large amount of count of inversions because 3, 4, 5, 8, and at this point 1, 2 and 6. Okay, now I is placed at here and j is placed at here. Now if array of I is greater than array of j, if array of I is greater than array of j, then we can definitely say that the left index size count okay, we can definitely say that if array of I is greater than array of j, then all the elements from the I in that array is also found a pair with 1. Why? Because this array is sorted order, so we are finding 1, 3, 1, 4, 1, 5, 1 and 8, 1, 4 pairs. So add plus 4 here, so we can find. So again I am repeating my word because I am not clear at that time. If array of I is greater than array of j, we need one array for sorting. If array of I is greater than array of j, then it found one pair of inversion. So we can say that every element from the greater than that point is also found a pair with the 1 because it is also inversion point. So we got the 4 point. Now whichever the smaller element, just add this into array and increase their count. Now just check, is 3 is greater than 2, again it is the found inversion. So again every point found inversion pair here. So 3, 2, 4, 2, 5, 2, 5, 2 and 8, 2. Again we got 4 counts here. Okay, now whichever the smaller, add this into array and increase the count of this. Now just check, is 3 is greater than 6? No, not. Then add this into array and update the index. Now 4 is greater than 6? No. So update here and add there is into this array and update the index. Is 5 is greater than 6? No. Update the index, add this into this. Now is 8 is greater than 6? Yes, it is greater than 6. Again we found another one pair plus 1. So whichever the smallest element, just add this and update their index. Now with one index is left, so this is a sorted order of this array. Now this is the approach to solve this question. We got 1, 9, 10, 11, 12, 13, 14, 15 counts, 15 inversion counts in this array. So I recommend you to pause the video here and code by yourself. Now I am assuming that you are code yourself. So let's start with the solution. Okay, so for the solution, let's do some code here first. Let's take input here fastly, int in n and input array, that is in form of vector array n comma 0 size, filling this array with I is at 0, I should be less than n, I plus plus c in array of I. Okay, now we need to call the one function that will calculate us the count, that is a merge sort, because we want to optimize our code. So let's call it the merge sort, and it takes us from array low and high, that is n minus 1 we are passing. So give me 1 minute, do me a full screen. Okay, now we are passing merge sort in merge sort function array 0 and n minus 1. It contains first 0th index and it is low and it is our high. Okay, now let's write this it contains one array that contains a sorted list. So vector of int merge sort, uh, just give a minute, copy it, paste it, merge sort, it has int of and percent array low int high. It contains array low and high. First work we have to do is finding mid, that is it is from low plus high divided by 2, so it is a medium element. So first call is from low to mid and second call is mid plus 1 to high. First call is this is the medium element and this is these two as. So first call is from, this is the mid element, sorry, this is the mid element. So we are calling first call is 0 to 3 and again the second call will be mid plus 1 to high. So the first call is vector of int, that is left call is merge sort array low and at the mid. Now the second call is int right, RIGHT, right merge sort array. So second call is mid plus 1 to high, mid plus 1 comma high. Now vector of int, we need merge list, so we are writing this name as merge equals to, let's call another function, that is merge sorted array. So it will contains left and right and it will give us return the fully sorted array. So we are returning here merged. Okay, we are returning here from merge. So the best case is if we are at low is equals to high and high is equals to low, we can say anything, we return the one array of one size, and it contains the array of low or array of high. So our best case is if low is equals to high, if this, then we need to return an empty array, one size array that contains base answer of 1 comma 0. So base answer of 0, it contains array of low, okay, and return here base answer. So it contains array of low. Yeah, if you want to say array of high also, then you can say. So let's make this function also, merge to sorted array. Now it returns sorted array, it returns the fully sorted array. So vector of int merge to sorted array, it contains vector of int and percent left and vector of int and percent right. So it contains two arrays, so we need to add them into one array. Now we need to initialize the global variable for finding the count. Here count is 0 here. Now we are at this position. Now what should we do? So for sorting two arrays in one form, so we need 3 pointers, I, J and K. I is used for left, it is accessing our left array, sorry, it is accessing our right array, GST, and it is accessing our final array. It contains fully final sorted list. So let's take this list also, merged, and its size is left dot size plus right dot size. Okay, now Let's run a loop over this. So if I is less than, until I is less than left dot size, and j is less than, right dot size. Okay, until and unless we run a loop. Now checking the first condition, that if left of j, if left of I is less than right of j, then we are updating our merged of k with left of I. Why? Or we need to increase I also and k also at this time. Why this? Okay, let's check this at this point where array of I is less than, right. See, okay, so this is our left and this is our right. Okay, so 3 is less than 4, so we need to update 3 first in the merge list. So we are updating 3 in merge list, and after that 4. So in the first part, now we are checking the else part here. If left of I, that means array of I is greater than array of j. So here is the main condition. So let's talk about that. Talk about this condition, that is, let's check. This is the array from the half section 5, 8, and this is the second array 2 and 6. Okay, now our I pointer is there and j pointer is there. Okay, what we are saying here, if 3 is greater than 1, if 3 is greater than 1, then it will be finding 4 pairs. The left this arrays dot size count here. Okay, again, if I is greater than j, then it will found a pair, that is from 3 comma 1, 4 comma 1, 5 comma 1, 8 8 comma 1. Why all this pair? Because it is sorted array. If this is the array's first element is greater than this second array's first element, then it will also follows again rule. That means if 3 is founding pair here, then 4 is also founding, 5 is also finding, and 8 is also finding. So our count formula is I is at 0th position. So left dot size, this is a left from left and it is a from right. So left dot size, that means 4 minus 1 0 0th position, 4 minus 0, it will give us a count as a 4. Okay, now so this is a formula. So let's try to write it here. Count plus equals to left dot size minus I. Okay, now fill the merge array with right of j plus plus, update the j and k as well. Now this is the formula. This is formula give us the inversion count. Again, after that, if we are checking only for this, in this while condition we are checking that is I is less than left. Okay, let's erase me this something. If the array size, if array contains 4 sides and second is 3 sides, then we are just checking that, and we are using the AND operator, that and operator, that is, if this contain, this represent I and this represent j. If I is less than left dot size, the size is 4 and j is less than right dot size and the size of this is 3. So because of the and operator, it only runs for the j is equal to 3 and one element is left. So we need to check this also. So what is the check for this? While if I is less than left dot size, then do the same work as we are doing here. Paste here, shift tab, so it will rearrange of again. While if j is less than right dot size, if this condition also possible, so do this thing and shift tab, rearrange this. After that, return our return merged array. Okay, so this is the code. This is the same code for the merge sort, but we are adding only this one, like it gives the count of inversion for this array. Okay, let's try to run this code. So we need to print the count also. So in the main here, let's print cout count end line. So it will print the count. So 3, let's try to submit this code. It is run for all the test cases. So only this one line is gives us count of inversion. All the code is merge sorted. All the code is merge sorted code, and this count is gives us, this line is gives us the count of inversion. So I hope you understand the question and the solution of this question. Thank you for watching.